The friction simulation is an innovative educational tool designed to help students understand the principles of friction on an atomic level. This simulation allows students to explore what happens when two objects are rubbed together and how friction causes materials to heat up. By providing a visual representation of the atomic interactions, the simulation offers a deeper understanding of the fundamental mechanisms behind friction. This simulation focuses on the atomic level interactions that occur when two objects are rubbed together. It illustrates how the surfaces of the objects interact at the molecular level, causing friction and generating heat. The simulation includes two main tools, a physics book and a chemistry book. The physics book is fixed and made of a harder material, while the chemistry book is movable and made of a softer material. This setup allows students to observe the effects of friction without the complication of both objects moving. Key components of the simulation. 1. Physics book. The physics book represents a harder material that does not move in response to the motion of the chemistry book. It is made of tightly bound molecules that are not affected by heat, providing a stable surface for the simulation. 2. Chemistry book. The chemistry book represents a softer material that can be moved across the surface of the physics book. The interaction between the surfaces of these books illustrates the atomic level processes that cause friction. 3. Molecular interaction. The simulation shows the molecular interactions at the surfaces of the books. When the chemistry book is rubbed against the physics book, the molecules on the surfaces interact, causing friction. 4. Heat generation. The simulation demonstrates how friction causes the materials to heat up. As the chemistry book is rubbed against the physics book, the kinetic energy of the moving molecules is converted into thermal energy, leading to an increase in temperature. This simulation provides a hands-on approach to exploring the principles of friction at the atomic level. By observing the molecular interactions and the generation of heat, students can understand the following key concepts. 1. Molecular interaction. When two surfaces are rubbed together, the molecules at the surfaces interact. These interactions cause resistance to the motion, which is experienced as friction. The simulation shows how the tightly bound molecules at the edge of the physics book interact with the molecules of the chemistry book. 2. Heat generation. Friction causes the materials to heat up due to the conversion of kinetic energy into thermal energy. As the chemistry book is rubbed against the physics book, the energy from the motion of the molecules is transferred into heat, raising the temperature of the materials. Material properties. The simulation highlights the importance of material properties in friction. The physics book, being made of a harder material, does not lose any of its molecules due to the heat generated by friction. This illustrates how different materials respond to friction and heat. This simulation offers several educational benefits, and they are as follows. 1. Interactive learning. The simulation provides an interactive and engaging way to learn about friction. Students can actively participate in the learning process by observing the molecular interactions and the generation of heat. 2. Visualization of abstract concepts. Friction can be a challenging concept to understand. The simulation provides a visual and tangible representation of the atomic level processes that cause friction, making it more accessible and understandable. 3. Experimentation and exploration. Students can experiment with different movements and observe the resulting molecular interactions and heat generation. This exploratory approach encourages critical thinking and problem-solving skills. 4. Real-world application. The simulation provides a practical application of the principles of friction, which are fundamental to many real-world phenomena. This helps students see the relevance of these concepts in everyday life. In conclusion, the friction simulation is a valuable educational tool that brings the principles of friction to life through an interactive and engaging context. By allowing students to explore the atomic level interactions that cause friction and generate heat, the simulation provides a hands-on learning experience that enhances understanding of this fundamental concept. This interactive approach not only makes learning more enjoyable, but also fosters critical thinking, problem-solving skills, and a deeper appreciation for the relevance of friction in the real world.